Hello everyone. Today we're looking at evidence for the electronic configuration of electrons in atoms. Now, there's reasons why we think there are shells. There's reasons why we think the electrons go into shells and to subshells. We need to look at some of those reasons, and it helps us explain some things. One of the main reasons why we think electrons go into shells and subshells is that if you take some hydrogen, for example, hydrogen gas, and you heat it up, then the gas gives off light, but it doesn't give off light all through the spectrum. It doesn't give off all the different colors. It only gives off certain particular colors and not any other colors. So here we have on the slide we have a picture of the emission spectrum of hydrogen. So hydrogen gives off bright light at this color when it's hot, and it doesn't give off light of these other colors along here, but then it gives off this blue light along here and doesn't give off any other colors until it gets to here and here and here. So it gives off colors at particular colors, not just all the different colors. So why is that? Now we need to try and understand and explain why hydrogen gives off light in particular colors but not all the colors. So down here we have a model of hydrogen, and there's the nucleus there. And further up, away from the nucleus, there is a place which is an energy level, that corresponds to a shell or a subshell. And an electron might be sitting here, but when the atom is hot, when it gets bumped around in a hot flame, the electron can actually get bumped up to a higher energy level, or maybe up to here, or maybe up to here. So that's okay. The thing is, though, that it's unstable up here. It actually likes to be back here at the lower energy level, and it can jump back down again. So if the electron jumps from this energy level down to this one here, like this, it has to get rid of that extra energy. And one possibility, well, what actually happens is that the electron gives off a photon of light that's like a light ray. Off it goes. Okay, so that corresponds to the light that is given off. It's funny, my drawings are disappearing. When it jumps from here to here, then the electron gives off some light. That was supposed to be red. Gives off some light. Okay, gives off a red light ray. Now, if the electron was bumped up higher in the flame and jumps from here to here, you can see that that is it's a bit further to jump. And so the color that gets given off is a different color. It's actually the blue color now. So this jump here corresponds to a blue light ray coming off. Okay, now what happens if it jumps from maybe way out here down to here? Okay, that's a different color again. Maybe that's the purple one. So a small jump corresponds to, on the red end of the scale, a medium-sized jump represents a blue color light, and a large jump represents a purple, or further along the spectrum along here. So the fact that the hydrogen gives off different colors means that we can conclude, we can make a deduction, we can figure out that the electrons are coming from different energy levels and jumping back down again. That is crazy how my colors keep disappearing. Look at that. Okay, so the lowest energy level is the 1s orbital, 1s subshell. Further up here we have the 2s, and then higher up is the 2p. Higher up again is the 3s, and then the 3p and the 3d. So if electron jumps from here to here, down there, then that's one size of jump. That's a bigger jump. That's obviously a bigger jump, and that's a bigger jump. Another possibility, of course, is it jumps from maybe here to here, or maybe here to here. So there's lots of different possibilities, which means hydrogen gives off lots of different colors. But when you look at the spectrum, just in this little area here, it just looks like that. So each subshell has its own energy level. When the atoms are heated up in a flame, electrons get bumped up from their subshell to an empty place in a higher subshell, but then they jump down again and they emit a photon of light, and that light is the same energy as the energy difference between the two subshells. That's why we think there are subshells. Okay, now we need to have a quick look at the order of the subshell. So this shell here sits here. This one, the energy level is about 2s is there, 2p is there, 3s, 4s, 3d. But just a second, look, the 4s subshell is actually at a lower level than the 3d. That means that when the electrons start to fill up these shells, as we get maybe bigger and bigger atoms with more and more electrons, they'll fill here, 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 here. And then, instead of filling the 3d, it actually fills the 4s first, and then it fills the 3d. And there's other complications further along where the subshells of one shell actually overlap with the subshells of the previous lower shell. Now we need some way of understanding how this all works. So the order of filling goes like this. First it's the 1s, then it's the 2s, then it's the 2p, then it's the 3s, then it's the 3p, then it's the 4s. That's where the change happens. Then we get the 3d, then the 4p. We don't go to 4d next, we go to 5s, and then 4d, 5p, 6s, 4f, 5d, 6p, and so on all the way through. So this little diagram can explain or help us predict the order of the filling of the shells. Now there are some complications that come along later, but don't worry about that. So for example, if I needed to do the electronic configuration of calcium, let's see, calcium, just get this pen organized. So calcium has 20 protons. So the electronic configuration is going to be 1s2, 2s2, 2p6, 3s2. Now you go to 3p6. Now we don't go to 3d. We now go to 4s2. And hopefully that comes up to 20. That's 10, and 10 makes 20. So there's 20 electrons, and you notice that the 3d, we haven't filled in the 3d because there's no electrons in the 3d. So that's the electronic configuration of calcium. We're not going to worry too much about higher electron configurations in this course, but there's one other thing I should mention before we finish up this session, is that valence, the term valence electrons refers to electrons in the outer shell. Electrons in the outer shell are called valence electrons. These are the only ones that are involved in chemical reactions. So one of the reasons that we are talking about these electronic configurations is that, look, calcium has got only 2 electrons in the outer shell. We can tell that from the electronic configuration, and this is actually important because this tells us a little bit about how calcium is going to react chemically, and that's where we're headed to. We're trying to find out, trying to explain the chemistry of calcium, why it reacts the way it does, what are its characteristics chemically, and a lot of it comes down to the fact for calcium that it's only got 2 electrons in the outer shell.